Hello and welcome to my science tutorials. In today's video, we are going to be talking about how to calculate the moment of a force. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics and physics. So let's begin. So the moment of a force. Now, the moment of a force about a point is defined as the product of the force and its perpendicular distance from that point, or it is the product of a force and the perpendicular distance to the line of the force. So simply put, the moment of a force is just the product of what? The force and the perpendicular what? Distance. Now this symbol is to represent perpendicular distance, so simply put, force times distance, and then the SI unit for force is what? Newton, and that of distance is meter, so it's Newton meter for the moment of a force. Now the moment of a force about any particular point depends on what? One, the magnitude of the force. Secondly, it also depends on what? The magnitude of the perpendicular what? Distance. So the moment of a force about any particular point depends on what? The magnitude of the force, and then what? The magnitude of the perpendicular distance. Now let's look at what the principle of moment says. The principle of moment. Now to summarize the principle of moment, all that it says is what? When we have what? A beam, okay, on a pivot and it is in equilibrium, the sum of the clockwise moment, okay, sum of what? Clockwise moment, okay, should be equal to what? The sum of the anti-clockwise moments. So according to the principle of moment, the sum of the clockwise moment, okay, should be equal to what? The sum of the anti-clockwise moment. Now so let's have a look at a diagram to actually explain what we are talking about, what? The sum of a clockwise moment and the sum of what? An anti-clockwise moment. So let's have the diagram that we see over here. Now if we look at the diagram over here really well, we can see that we have a force A, okay, and then another force what we call B. Now the distance between force A and then the fulcrum or the pivot over here is what? The distance X, and then the distance between what? The pivot and then the force B here is what? The distance Y. Now if we look at how clock rotates, or we look at this direction, okay, we can see that this direction, or moving in this direction, is what we call the clockwise rotation, or simply put, what? The clockwise moment. Okay, so any force that will multiply the distance and it is what? In this direction, we call it what? The clockwise moment. And then the other way around is what we call the anti-clockwise moment. Now if we look at this force, okay, now the moment of a force has to be what? The product of a force and then the distance between the force and the pivot. Let's take that into consideration. That is very, very important. The distance should be between the force and then the pivot, and not any other distance between two forces or any other places. It should be between what? The force and then the pivot. Now if we look at the clockwise moment in this example, we can see that this force over here multiplies the distance Y, and it is what? In the direction of what? The clockwise moment over here. Okay, so we can say what? Our clockwise moment for this diagram, our clockwise moment being equal to what? The anti-clockwise moment. We can say that our clockwise moment in this example is what? The product of the force B and then the distance Y over here, because what? If we look at how the force is acting downwards and then the distance, we can see that it is moving in what? The clockwise direction. So our clockwise moment is what? BY. Okay, so plus, now if we look at this, we can see that there's another force over here, and then there is a small distance between what? This side and this side over here. Okay, Now we can see that if, assuming we have a value for this distance, small distance over here, okay, that distance is also what, in a clockwise direction, but because the distance over here, okay, is not between the force and then the fulcrum, we will not consider that as a clockwise moment. All right, now if we look at the anti-clockwise direction, we can see that the force A and then the distance x are in what, the anti-clockwise direction. Okay, so it means the clockwise moment is just what, by, then there's nothing else over here. So let me erase that. Okay, so this should be equal to what, the anti-clockwise moment is what, the product of this force over here and then the distance over here. We can see that this distance is between what, the force and then the pivot. Okay, so the product of the force and then the distance over here moves in what, the anti-clockwise direction, as the arrow is showing over here. So our ax should be here. So in this case, the sum of the anti-clockwise moment being equal to anti-clockwise moment being means what, our product of what, the force b and then y, the distance y, is equal to what, the product of what, the force a and then the distance x. Now let's have a look at another diagram to further understand the clockwise moment and then the anti-clockwise moment. Now if we look at this diagram very well, we can see that we have two forces acting downwards on this particular what, beam, or this particular line that we have over here, and then the pivot, that is the support, is over here at the middle. This is just to show the actual division between the distance, that is the division between the forces to actually measure the distance accurately. Now we can see that force A, okay, force A acting over here has the distance between the force and then the pivot to be what, the distance m that we have over here. So it extends from what, A to what, to the middle over here. Now the force B has the distance what, k, that is between what, the force B and then the distance what, the pivot over here. Now force C has the distance L, and then that of force D has the distance what, N. So if we take into consideration the principle of, or the principle of what, moment, we can say that what, our clockwise moments, sum of what, clockwise moments, okay, should be equal to what, the sum of our anti-clockwise moments. Okay, so let's look at the clockwise moment. Now we can see that this direction, this movement, okay, in this movement is what, this is our what, clockwise direction, and then this direction we have over here is what, our anti-clockwise direction. All right, let's look at the forces that are acting in the clockwise direction and that of what, the anti-clockwise direction. So if we look at the clockwise direction, we can see that what, the force D and then the distance N, okay, are in what, the clockwise direction, okay, and the distance is between what, the force D and then the pivot. So we can consider what, the product of the force D and then the distance N as what, a clockwise moment. So we have what, dn as one of what, the clockwise moments. Now if we consider the force C and then the distance L, we can see that it is also what, in the direction of what, the clockwise direction. Okay, so we can say that what, the product of the force C and then the distance L is also what, a clockwise moment. So we have what, CL is equal to, now if we look at this side, we can see that the force A and then the distance M, okay, the distance M is between the force A and then the pivot. So we can consider that to be a what, a moment, and then what, it is in what, the anti-clockwise direction, because if you look at this direction, it is going in this way, the force is multiplying this distance in this direction, so it is what, an anti-clockwise direction. Okay, so we have what, AM plus what, the force B and then the distance M, the distance K is also what, in the anti-clockwise direction, so we have what, BK. So we can see that from this diagram we have what, the product of the force D and then the distance N making one moment, and then the force C, and then the distance L also making another moment. So the sum of these two makes what? The clockwise moment. And then the sum of the force A multiplied by the distance M, and then the force B multiplied by the distance K also makes what? The anti-clockwise moment. And then what? It is equal to what? The sum of what we have over here as the clockwise moment. Now let's have a look at another diagram to further expand our understanding of what? Clockwise moment and anti-clockwise moment. Now if you look at the first two examples that I gave with the diagram, you could see the forces were only acting what? Downwards on the what? On the straight line or on the beam that we have. But in this example we have what? Two forces acting upwards, and then two forces what? Acting downwards. Now we have force 1, and then the distance between the force 1 and then the pivot is what? Distance x1. The same way we have force 2 and then distance x2 as the distance between the force and then the pivot. And the same applies to what? Force 3 and then force 4. Now if we take into consideration the principle of moment, we could say what? The sum of what? Clockwise moment should be equal to what? The sum of what? Anti-clockwise moments. Alright, now this is where it gets interesting. Now this movement is the clockwise direction, and this is the what? Anti-clockwise. Alright, so if we look at the clockwise movement, let me take the force F2 first. There is a distance between what? This F2 and then the end of the bar over here. But because the distance over here is not between what? Force F2 and then the pivot, we cannot consider that as a clockwise moment, even though the distance, the force and then this distance over here are in the direction of clockwise moment. Okay, but we will not consider this distance because what? It is not between what? The force and then what? The pivot. So let's consider force F3. Now if we consider force F3, we can see that the distance between F3 and then the pivot is what? Is in the clockwise direction, and then the distance is between the force and then the pivot. So F3 multiplied by distance distance x3 is what? A clockwise what? Moment. So we have what? F3 x3. Okay, so plus. Now if we look at force F4 over here, if we look at the clockwise direction, we could see that this force over here has to multiply the distance over here for it to be a clockwise what? Moment. But because the distance over here is not between what? The force and then the pivot, we will neglect it because it does not count as a clockwise moment. Now let's look at force 1. If we take this direction and we go to the top, we could see that what? Clockwise moment, this will go to the top and then curve at the top over here to form a cycle. Okay, so we can see that the product of what? The force F1 and then the distance what? X1 also constitute what? A clockwise moment. So we have what? F1 x1 as another what? Clockwise moment. Alright, it's equal to, now let's look at the anti-clockwise moment that we have. So let's start with F4. Now F4 and then x4, the distance is between the pivot and then the force. So the product of F4 and then x4 over here constitute an anti-clockwise moment. So we can say what? F4 x4 is an anti-clockwise moment. Plus, now if you look at F3, the distance is what? Is in this direction, which is what? In a clockwise direction. So we neglect that. Now if we rotate this in an anti-clockwise direction and we come to the top, we can see that F2 over here, it is also moving in the anti-clockwise direction if we multiply F2 with what? X2 over here. Okay, so that also forms what? An anti-clockwise moment. And then if we move this and we come to the top over here, the force F1 multiplied by this distance is also a moment, but because the distance is not between what? The force and then the pivot, is not considered as a moment. Okay, so if we look at this diagram, the sum of what? The clockwise moment is what? F3 x3 plus what? F1 x1 is equal to the sum of the anti-clockwise moment, F4 x4 plus what? F2 x2. Now with this understanding of what? Clockwise moment and anti-clockwise moment, let's go ahead and have a look at some few examples to actually appreciate the principle of what? Moment. So let's go ahead. Example number 1. Okay, so the example number 1 is just what? Similar to the previous diagram that I just showed earlier on. And so we have force F1 to be 20, then the distance is what, 30. We have the pivot over here. This distance is what, 25 centimeters. We don't know the force F2, and then we have the other parameters. So we have to find the distance, the force F2. All right, so let's write our solution. Now if we look at our solution, it means our what, from the principle of what, moment, we could say what, sum of what, clockwise moments should be equal to what, sum of anti-clockwise moments. And then that is what, if we look at the clockwise direction, we have what, F3 multiplied by this distance constitute what, a clockwise moment, like we saw earlier on. So we have the force 20 multiplied by what, multiplied by the distance 50 centimeters. Now the 50 centimeters, the distance has to be in meters, so we need to convert the 50 centimeters to 50 what, meters, which is what, 0.5. now plus, now the clockwise moment, any other force that is constituting the clockwise moment over here is the F1 and then the distance over here. So we have what, 20 multiplied by the distance 30 over here, which is what, 0.3. And this is equal to what, the anti-clockwise direction, we have the force 40 over here and the distance 40 over here, which is 0.4, plus what, if we go to the top, we could see F2 and then the distance what, 0.25, as what, 25 centimeters over there. All right, so 20 multiplied by 0.5 is 10. 20 multiplied by 0.6 is, this is 10, plus this is 6, is equal to, this will give us what, 16 plus what, 0.25 F2. So we have 16 is equal to what, 16 plus what, 0.25 F2. So if we send this 16 to the other side, we have 16 minus 16 is equal to what, 0.25 F2. So if I use this side, we could see that 16 minus 16 is 0, is equal to what, 0.25 F2. So if we divide both sides by 0.25, we still get what, our force F2 to be what, 0 newtons. Okay, so it means the magnitude of F2 over here is just what, is 0. So there's no force acting upwards in this direction. All right, let's have a look at the second example. So example number 2, a uniform bar with weight 20 Newton rests on what, 2 supports, that is P and Q, as shown in the diagram over here, P and Q. Now the weights are suspended as shown in the figure below. Calculate the reactions at what, P and Q on the support. So we are to what, calculate the value of what, the force X over here, and then the force what, Y over here. They are the reactions, okay, of what, P and Q. All right, so this is where it gets interesting. We could see that this diagram, we have what, 2 fulcrum or 2 pivots, okay, but we said the moment of a force is what, the product of the force and then the distance between what, a fulcrum or just a pivot. Okay, so now that we have 2 pivots over here, it will be difficult for us to find what, our moment easily. Okay, so to solve this problem easily, this is how we do it. Okay, so first of all, let's find y. Okay, so to find y, okay, let's take the moment at point P. Now if we are taking the moment at point P, it means we are saying what, only the pivot P is going to be our pivot that we are going to use to what, to count the moment. So it means we are going to ignore the pivot Q over here during the calculation. Okay, now once we ignore the pivot Q over here, it means the reaction Y over here will still exist because this pivot is not existing. Okay, now if we take the moment at the point P over here, it means what, the reaction X will no longer exist. Let me take that again. To find Y, we need to take the moment at the point what, P over here. So it means we are going to maintain P as our what, as our pivot, and ignore what, the pivot Q. Now once we maintain the P, the reaction will no longer exist on it, but this reaction will exist. So this whole diagram that we see over here now looks like the diagram that we have over here. Okay, so you could see we are maintaining the pivot P, but the reaction over here does no longer exist, so S is no longer in existence. But we are ignoring the pivot P, so there's no the pivot Q, so no pivot over here, but the reaction Y still exists. So we could easily go ahead and find what our clockwise moment, and we equate it to what our anti-clockwise moment, and we can what find our solution. So let's go ahead and look at that. So we have our clockwise moment, the sum of clockwise moments to be equal to what the sum of what the anti-clockwise moment. Now as usual, this is our clockwise direction, and then this is our anti-clockwise direction. Now let's look at how we are going to solve this example. Let's pay very close attention. Now the force over here at the bottom over here, okay, F3, okay. Now the distance between F3 over here to the pivot over here, okay, includes what the sum of 2, 3 and this 2 over here, okay, and it constitutes what a clockwise direction or a clockwise moment. So for a clockwise moment, the first force over here F3 will count, okay. So we have the force 5, then into bracket the distance is what from here to what where the pivot is, so it becomes what 2 plus 3 plus 2, which is what 7, okay. Then plus, now if we look at the distance, the force 20 over here, we could see that there's a distance between this force and then this pivot, and it is in the clockwise direction, so it also counts. So we have 20, and then the distance between the force 20 and then the pivot is what 2, okay. Then we equate these two. Now if we look at this force over here, you could see that the distance is not between this force and then the pivot, it is this way, so it doesn't constitute any clockwise moment. And if we go to the top over here, the Y over here by multiplied by these two also constitute a clockwise moment, but because the distance is not between what the pivot and then this force over here, but it is between the force and then the end, we neglect that, okay. So now let's take the look at the anti-clockwise moment that we have. So anti-clockwise moment, the first force over here is 15, and then there's a distance between this force and then the pivot, so we take that. So we have 15, and then the distance is what 3 as our first anti-clockwise moment, okay. Now if you look at this force, okay, we can see that the force 20 has a distance what 5 over here, which means from here to here, okay. But this distance is not between the force and then the pivot, it is between the force and then the end of the bar, so we do not consider that as what an anti-clockwise moment. Now if we still take this as the anti-clockwise moment and we go to the top, we could see that the reaction Y over here has a distance between what the force Y over here and then the pivot over here. If we take this to the top, okay, in this direction, and it goes to the top this way, okay, so it means what we have another anti-clockwise moment over here, and this what the product of the force Y, and then the distance between the force Y and then the pivot is what 3 plus 2, which is what 5, okay. So now we've what demystify the clockwise moment and then the anti-clockwise moment, so we can just go ahead simply or easily and solve our solution. So we have 5 multiplied by 7, we have 35, plus what 20 multiplied by 2 is 40, this is equal to what 15 by 3 is what 45, and then we have plus 5y, so this is what 75. We bring this 45 over here, so it becomes minus 45 is equal to what 5y. So if we 75 minus 45, this is 30 is equal to 5y. So we divide both sides by 5, we get what y is equal to what 6 newtons. So it means the reaction of y over here, or the force y over here, is what 6 newtons. All right, so now let's find what our x now. So let's find x. Now to find x over here, it means what we need to take what the moment about the point what q. Now the same way like I explained earlier, if we take the moment at q over here, it means what this force y will no longer exist, and this pivot will also not exist. So this whole diagram now looks like what the diagram that we have over here. So we only have the pivot q over here because we are taking the moment about this point or this pivot, and there's no reaction y over here but only the reaction x, and there's no pivot over here. So the same way we say what our clockwise moment should be equal to what our anti-clockwise moment. Okay, now let's look at the clockwise moment that we have. If we move in this direction, or in our clockwise direction, you could see that the force F2 has a distance 2 meters between what the pivot Q and then the force over here, so it constitutes what a clockwise moment. So we have 5 multiplied by what 2 meters, constituting the first clockwise moment that we have. So plus, now if you look at the force 20, it has a distance 2 plus 3 over here, which is 5, but it's not between, the distance is not between what the force and then the pivot, so it is not a clockwise moment. Now this force F1 has no distance in this direction or in the clockwise direction, so we neglect that. Now if we rotate this and we go to the top, we could see that the force X over here, okay, is in the clockwise direction with what the pivot Q over here if we move this way to the top. And then the distance between the force X or the reaction X and then the pivot Q over here is what 5. So we have what X into bracket 5 is equal to, now let's look at the anti-clockwise moment. The anti-clockwise moment is in this direction, so the force 15 over here has the distance 3, 2 and 3 as the distance between the pivot Q and then this force 15. So we have 15 into bracket 3 plus 2 plus 3, which is what 8, then plus, then if you look at the force 20, we have the distance 3 meters between what the force 20 and then the pivot Q, so we have what 3 over there. So like that we are done with the clockwise moment and then the anti-clockwise moment. So we could see that here is what 10 plus what 5x is equal to 15 by 8 is what 120 plus what this is what 60. So we have what 5x is equal to, this is what 180, then we bring the 10 over here, it becomes minus 10, so we have 5x is equal to what 170. We divide both sides by 5, we get our x to be 34 newtons. So the value of our x is what 34 newtons, and then the value of our y is what 6 newtons, as we found in the previous example or in the diagram I showed earlier. Now you could see that if you were to use this diagram and try to find your way around the clockwise moment and then the anti-clockwise moment, it becomes difficult for you because of the two pivots that we have over here. So if you have any example that looks like this, try to find a moment about 1 point. So if you are finding about P, it means what the pivot Q no longer exists and then the reaction X will no longer exist. The same way, if you are finding around what the pivot, if you are finding the moment about the point Q, it means what the pivot P will no longer exist and then the reaction Y will no longer exist too. So you could easily have the diagram in this way and you can easily find what your clockwise moment and then the anti-clockwise moment. Now let's have a look at another example. Alright, example number 2 and our last examples in this tutorial. So we are to consider the diagram below and find the values of what R1 and R2, a piece of cake. So like I said, if you have the two pivots, you cannot find the R1 and R2 easily. It becomes what confusing because this is what distance between a force and then a pivot. This one is also there's a force and then a pivot, a force, a pivot. Then it becomes very difficult for you. Okay, so you need to take one of the pivots, okay, as your only pivot, and then you find your way around it. Okay, so for this example I want to take the moment at point O, at point O. So if I'm taking the moment about this point O, it means point P or this pivot will no longer exist, and then this reaction R1 will also no longer exist, okay, because I'm taking the moment at this point. So this whole diagram becomes this beautiful diagram we have over here. So you could see we have the pivot O still over here, then we have the reaction R2 still existing because the pivot P is no longer here. So this way we can easily solve for our R2. So if this is now our new diagram, we know that our clockwise moment should be equal to our anti-clockwise moment. Okay, So let's look at the clockwise moment. Okay, clockwise moment, if you look at this force over here moving in the clockwise direction as the arrow is showing over here, you can see that the distance between this pivot, the pivot O over here and then the force 30 over here is what? 3 plus 4 plus 2 between this force and then this pivot. So it constitutes what? A clockwise moment. So we have 30 into bracket. 3 plus 4 is 7 plus 2 is 9. So we have 9 over here. Plus we have the force 20 Newton over here, and the distance is between what? O and then this force over here. Okay, there is a distance between the force and then the pivot, and it is what? In the clockwise direction, as we can see over here, this direction. So it means we have what? 20 and then what? 2 meters. Okay, now if we look at this this force and then this distance is not in the clockwise direction, so we ignore that. And then these are not forces, they are just to show the accurate distance between the pivot and this. So these are not forces. And then if we take R2 over here, the distance is not between the R2 and then the pivot, so that is not a clockwise moment. So this is equal to, this is 20 and then the distance is just 2. So what is here? Is 2. Sorry about that. So if we take the anti-clockwise direction, this is the anti-clockwise direction, you could see that the force 40 newtons over here has the distance 4 between what? The force itself and then the pivot O. So we have what? 40 and 4 over here, plus this force also has a distance, but it's not between the force and then the pivot, so we ignore that. So if we go to the top, you could see that the R2 over here is also in an anti-clockwise direction, and then the distance exists between what? From here to here, which is now 6. We have what? R2 multiplied by the distance between the R2 and then the pivot in the anti-clockwise direction, that is in this direction, is what? 4 plus 2, which is what? 6. So we can simply just solve this. 30 multiplied by 9 is 270, plus this is 40, is equal to what? 40 by 4 is what? 160 plus what? 6R2. So it means this side is now 310 minus, we bring the 160 over here, is equal to what? 6R2. So this is what? 150 equals what? 6R2. So our R2 becomes what? 150 on 6. So finally our R2 is what? 25 newtons. Alright, so now let's take the moment about the pivot what? P, and then we can find what? R1. So if we take the moment about the point P to find what? Let me write that down. Moment what? At point P to find R1, our diagram becomes like this. So we take the moment at P, we no longer have the pivot O over here, but we have the reaction R1, but we don't have the reaction R2. Okay, so let's take our clockwise moment to be equal to what? Our anti-clockwise moment. Alright, so if we take the clockwise moment, that is in this direction, you could see the force 30 over here, and then the distance, this 3 meters between the force and then the pivot over here, constitute a clockwise moment. So plus, you could see there's no pivot over here, so these forces all will not constitute a clockwise moment. Now if we still rotate this to the top, we could see that what? This is also in a clockwise direction. It means what? R1 multiplied by the distance 2 plus 4, okay, this distance over here, the total distance over here, constitute what? A clockwise moment. Okay, so we have what? R1 multiplied by what? 6, and that is equal to, now let's look at the anti-clockwise moment. So if you look at the anti-clockwise moment, we have the force 40 over here, then the distance 4 plus 2 plus 4 over here, okay, because the distance is between this force and then this pivot, so it's a moment. So we have 4 t into bracket 10, that is 4 plus 2 plus 4 making 10. Now this is also an anti-clockwise moment because it is in this direction. Okay, so we have plus 20 into bracket 4 over here. Now this force 30 over here has no distance between what? The force itself and then the pivot in the anti-clockwise direction, okay, as in this direction. So that is all for what? The anti-clockwise moment. So from here we could see that 30 by 3 becomes what, 90, plus what, 6r1 is equal to 400 plus what, 80. So we have 6r1 to be equal to what, 480 minus what, 90. So we have 6r1 to be equal to what, 390. So if we divide both sides by 6, we get what, our r1 to be equal to what, 65 newtons. So we could say that what, our r1 is 65 newtons, our r2, as we solved in the previous example, is what, 25 newtons. So we have r2 to be what, 25 newtons. So yeah, thank you so much for watching. This is how we can simply deduce a new diagram from what, an old or a given diagram, to find a new one which is much more simpler for us to solve, to find our what, clockwise moment and anti-clockwise moment. And like I said, if you are given the diagram, okay, in this form, okay, try to take the moment about just one of the pivots. So if you take it about this pivot, okay, it means the reaction over there will no longer exist, but the reaction at the other pivot will exist, but not that pivot. The same way, if you take the moment over here at this point, it means what, this pivot will exist, but then this reaction will also exist, then this pivot will no longer exist, and then this what, reaction will also not exist. Okay, it is more like a diagonal sort of thing. So if you take the moment at O over here, the reaction R will exist, but then this other diagonal will vanish to give you a diagram like this. And if you take the moment about this point, okay, it means this diagonal will exist, and then this diagonal will not exist, and then you could what, simply solve for your what, your clockwise moment and then anti-clockwise moment. You equate them, and then you get your final answer as simple as A, B, C. So thank you so much for watching, and I will see you in the next video. Before we close, if you're not a subscriber, please do subscribe to the channel, because it really helps and motivates us to create more beautiful and awesome tutorials like this for you guys. So thank you so much for watching, and I will see you in the next video. Bye bye.